So for accidental errors, we answered only up to number 4. So right now, let's answer number 5. So number 5, we're given another case, given probable error E. So if that's the case, weight is just 1 over E squared. Okay? So to recall, case 1, if given number of measurements N, so this is your value for W and V. Case 2, if you're given B, so again, these are your values for W and V. And then if you're given error, E, this is your equation for W. So most likely, if you're given error, there's only one thing to solve for, or there's only one thing that's being measured. So we're going to use this equation most of the time since it's always for single unknown. Okay, so let's look at our problem. Determine the most probable value of length AB, and considering this data. So we're just measuring length of AB. Again, that's a single unknown. That's why we're using this equation. And then your values of E. So to solve for this, like what we did previously, as you can see here, we're just gonna create a table. So number 5. Okay. So let's first write out our X, and X is the measurement, and that is this one. So 5.5132. Next, let's also include the error. So error is positive negative 2436. Okay. So next step, after getting your X and E, is solve for your weight, your W. Okay. And then again, the equation for W is given 1 over E squared. So I'm just going to finish solving for this. So please just follow along. You may solve as well, but I'm not taking recitation yet. So 1 over E squared, so that's 1 over 0.2 squared, so that's 25. Okay. And then this is 1 over 0.4, 6.25. 1 over 0.3. I will use fraction because that's in decimal. I want to use fraction so that I don't have to store this in my calculator anymore. And then 1 over 0.6 squared, that is 25 over 9. Okay. And then, now that we have WX, let's look. Now that we have W, let's look. We'll use this, so it's summation of WX over summation of W. So I need to do both. Let's solve for that. So just summation of this. Okay. So adding all of that, I believe you'll get 1625 over 36. Again, I'm using fraction just so that I don't have to store this in my calculator. 1625 over 36. Okay, and now let's do WX. So 25 times 5.5, that's 137.5. And then 31.875. And then 530 over 9. And then 130 over 9. 25 over 9 times 5.2. Yeah, 130 over 9. Once again, we have to get the summation of that. So that's summation of WX. And we should get 5825 over 24. Okay, so now we have all of the things we need to get most probable value. So MPV, that's just summation of WX over W. Okay. And then, so subbing here, divide by this, our final answer would be 5.38. Okay, that's our answer. So any questions for number 5, please answer in the chat. Again, just write clear or no questions, none, if you don't have any questions. Okay, great. So that's it for distance measurement. Our next topic, okay, I believe I've already uploaded this in your Blackboard as well. It's area measurement by tape. Okay. So we're done computing distance. The next step is your area. Okay. So there are several methods to get the area of a lot. Okay. So first, let's talk about your trapezoidal rule. So if a field is bounded on one side by a straight line and on the other by a curved boundary, the area may be computed by using or by the use of a trapezoidal rule. Okay. So perpendicular offsets are drawn and measured at regular intervals. The area is then computed using that formula. So let's talk about how we got that formula. Okay. So trapezoidal rule. Okay. So once again, this can be used if one of our boundaries is a straight line and then the top part is a curved line. Okay. And then remember, what we'll do is create perpendicular. Okay, back. So again, we're creating perpendicular offsets, and they are drawn at regular intervals. Okay, so let's do that. So offsets at perpendicular, regular intervals. Okay, let's choose a different color. Okay. Let's say that. Okay. And then let's call this regular intervals as D. Okay, distances between your offsets. So in order to do trapezoidal rule, after getting your offsets, you should also get the height of these points. So let's call this H1, H2, H3, and H4. Okay. So what we'll do here is we'll consider now our divided areas as trapezoid. So for example, and instead of a curved line, this is going to be considered a straight line. And as you can see, you have a trapezoid. Same thing here, instead of a curve, this will be reduced to a straight line. So this is a trapezoid, and then so on and so forth. So therefore, let's solve. If you remember, the equation of a trapezoid is just base 1 plus base 2 over 2 times height. Okay? So we're gonna look, let's consider this area first. Let's look at it this way. So this is your H1. I'm gonna rotate it so it's easier to see. Okay, your H1, your straight side, so this is your D. Okay, and then this is your top area. This is your H2 rather. Okay, and then this is the top edge. So area of a trapezoid again is base 1 plus base 2, so that's H1 plus H2 over 2 times height. In this case, our height is just D. Okay, so let's do The same thing for all of the areas. So plus, now considering this area. So that would be h2 base 1 plus base 2 over 2 times height d. And then lastly, h3 plus h4 over 2 times d. So can anybody tell me the common factor of all of these equations? And correct, the complete common factor. So it's correct, Geraldine and Sebastian. So it's d over 2, Lazaro Cruz. Okay, it's d over 2. So let's factor that out. Okay, since it's a common factor. And then let's copy what's left. So that's h1 plus h2 plus h2 plus h3, then plus h3 plus h4. Okay, let's combine like terms, your h2 and your h3. So d over 2. Okay, h1 plus, there's 2h2 here, so twice h2 plus twice h3 plus h4. Now we can reduce h2 and h3 as your, we can factor out 2 for h2 and h3. So d over 2 times h1 plus twice h2 plus h3 and then plus h4. And again, h2 and h3 are just your offsets in between your first and last one. Okay, so the general equation now for area using trapezoid method would be d over 2. h1 is the first ever offset. Okay, again, h2 and h3 are your intervals or intermediate offsets, meaning the one in between. So twice hi, or summation of hi. And then the last offset, let's call that hn, where n is the number of offsets. So in this case, that would be h4, since there's 4 offsets. Okay, and that's your equation. So that's how trapezoidal rule came to be. D over 2 h1 plus 2hi plus hn. Okay, or again, d, distance between offsets, h1, length of first offset, hi, sum of lengths of all intermediate offsets, and hn is the length of the last offset. So for us to have a better understanding, let's have an example. Okay, number 1, if the offsets from a straight line AB to the curved boundary DC are the following, and are at equal distances of 30, what is the included area between the curved boundary and the straight line? So your straight line is this top portion, this is your curved boundary, okay? So meaning I can use trapezoidal rule. Again, you can use trapezoidal rule if your boundary is straight and then curved. And this image fits that condition. So let's recall, okay, this is our equation. Let me copy that for our solution. Okay, so area is d over 2 okay, plus hn. Okay, so looking at example number 1, can anybody give me what's the value of d? Correct, 30. It's also given here. So correct, Gabriel and Zaira, Penoliar, Casople. Okay. So if it's not given here, the way to figure out what d is just the distance between the offsets. and it's given in the problem itself, equal distance of 30. Okay, so that would be 30 over 2 times h1. H1, so that's your first offset here, that's 35. Okay, if you can't see it, let's zoom in. Okay, 35 plus twice hi, everything in between, so 25 and 30, and then 40. So 25 plus 30 plus 40, and then plus the last offset here, which is 10. So plus 10. Please solve. What's the answer? Okay, correct. Jericho and John. So Furiscal Daguno. Okay, so 3525. So there's no units given, I believe. Okay, someone's mic is on. Please turn it off. So there's no units here. So in the quiz, I'll provide you with the units. So in this case, the standard unit for measurement is, or for distances is, for area rather, is meter squared or square meters. Okay. Yeah. So that's it for trapezoidal rule. Next, let's have Simpson's 1/3 rule. So this rule is applicable only if ordinates are odd, meaning there's even number of divisions. And if the number of ordinates is even, the area of the last division may be calculated, separated, and added to the result obtained by applying trapezoidal rule to the two remaining ordinates. So even if the first or last ordinate happens to be 0, they are not to be omitted from Simpson's 1/3 rule. And this is your equation. So it's d over 3 h1 plus hn plus 2h odd plus 2h even. H1 is the first offset. Hn is the last offset for your Simpsons 1/3 rule. H odd is offsets at odd intervals, and then H even is offsets at even intervals. So first thing we need to do, if we're using Simpsons 1/3 rule, is to check, are your intervals odd or even, or divisions are odd or even. Okay. So we can only do Simpsons if ordinates are odd. Okay. So, or even, again, even number of divisions. So let's look here. Let's have our example. The following offsets are taken from a chain line to an irregular boundary towards right side of the chain line. Compute the area. Okay, so chainage. So chainage, if you remember from our first lecture, we're using chain method. Okay, so they use a chain for linear measurement, etc. And then we have taken offsets at certain intervals. So that's what chainage means. And at different points of your chain, yeah, these are your offsets. So 0, 25, 50. Again, if we draw that here, this would be the 0 mark, the 25 mark, the 50 mark of your chain, and so on and so forth. And then this reading would be 3.6, 5, 6.5, etc. Okay? So the first thing that we have to do is to know, are these offsets odd or even? Okay, so let's do that. So let's count the number of ordinates. So that's 1, 2, 3, 4, 5, 6, right? Ordinates are the numbers of offsets. So 1, 2, 3, 4, 5, 6. It's even. And again, the rule here is it's supposed to be odd. So I can't apply Simpson's 1/3 rule to the entire thing. Okay? But again, as mentioned here, what you can do is you're gonna leave the last area and then do Simpsons 1/3 rule on the first few offsets and then use trapezoidal rule for the last area. Okay, so let's do that. So I'll try drawing this for us to better understand. Okay, Simpsons 1/3 rule. Okay, again we have chain age. Okay, this is your 0 mark. Okay. Okay, irregular boundary towards the right of the chain line. So this is your chain line. This is your irregular boundary to the right. Okay, so let's say this. So the first offset is this, and it's at your 0 mark, and its height is 3.6. And then here at your second mark, this is your after 25 meters. The height is 5.5. 5. Okay, 5. And then here, 50. This is 6.5. Here at 70, 75 after 25, 5.5. And then at 100, it's 7.3. And then at 125, it's just 6. So this is just a rough representation. This is not how the actual area looks. You can make it more accurate, but this is fine. So again, since this is even 1, 2, 3, 4, 5, 6, okay, you're gonna leave out this last part. So instead, let's use this. Okay, this would be your Simpsons 1/3 rule. Okay. And then the remaining would be trapezoidal rule. Okay. So Simpsons trapezoidal. This is using Simpsons 1/3 rule. So let's do that. Area. Okay. So considering Simpsons 1/3 rule first, the equation there would be d over 3. Can anybody give me what's d? Okay, very good. Zyra Penoliar and Carl Arreglado. So it's 25. Again, d is just distance between offsets. It's even, or rather, it's consistent at 25 meters or 25 units per offset. So 25 over 3 times h1 plus hn. Again, h1 is the first. That's easy to spot. That's 3.6. What's hn for Simpsons 1/3 rule? Can you please give it to me? What's hn? Okay, very good. It's 7.3. So correct, Geraldine and Ardiel. Lapid Lazaro. Okay, it's 7.3 because again, Simpsons is only up to this point because we're only supposed to use odd ordinates. So plus 7.3. Okay. And then plus twice even, twice odd, 4 even. So twice. Next, we have to look for your odd ordinates. So to get odd ordinates, so this is your 1, 2, 3, 4, 5. Okay, so odd falls into the odd numbering. So meaning your 3. 1 is already taken, that's your HI, so you're gonna use 3. Okay, and then 5 is the last ordinate, is the last ordinate, 7.3. So again, you can't use that. You're gonna only use the middle ones. So there's only one, it's just 6.5 rather. Okay, and then plus 4 even. So that's where 2 and 4 are. So that's 5 and 5.5. So plus 5, 5 plus 5.5. Okay, and then we're not done. That's only the area. Using Simpsons 1/3 rule, I need to do this as well. So that's using the area of a trapezoid, which is again base 1 plus base 2 over 2 times this distance between them, or height. So base 1 plus base 2, right? This is already your trapezoid. So 7.3 plus 6 over 2. Height is this, which is we already know to be 25. Right? That's already the D. So times 25. And now, please compute what's the final answer. Okay, good. It's 715.42. So correct, Gabrielle and John. First Calmar. Hmm? Okay. Akasokle, sorry. Okay. So it is 715.42. Again, I don't think there's any units given here. So we're gonna use meters. So square meter or meter squared. Okay. Any questions for this problem? Please answer in the chat. Okay, great. No questions. Let's move on to the next. Which is coordinate method. So this method is a bit tedious. You'll see why in a bit. Okay. So this is basically your answer. If you're instead of given measurements to a point, you're given coordinates, hence coordinate method, with reference to a Cartesian plane. So this is your x and y axis. These are the points of interest. Okay. So the way to get this area is to use this equation. So 1/2, and then you're gonna choose any point as your x1, y1. Okay. And then you're going to move clockwise from that point. And then the equation would be the x-coordinate of the first point multiplied by the y-coordinate of the second point plus the x-coordinate of the second point times y-coordinate of the third point, and so on and so forth until you go back to the first coordinate. And then subtract, you're going to do the opposite. So the x-coordinate of the second point minus the y-coordinate of the first point, and so on and so forth. Okay, so you may write your set of points this way. x1, y1, the first point, x2, y2, second point, x3, y3, second point, and so on and so forth. Okay, and then it's just being multiplied this way, x1, y2, x2, y3, and then minus this way, x2, y1, x3, y2. Okay, you can do that. Or to save time, you can just look at your drawing. And again, it's always counterclockwise direction. Okay, so let's start. Okay, so this is the data gathered. Okay. So you have your points A, B, C, D, and E. So you're going to choose any point as your first point. So to be consistent, I'll choose point A as my first point. So this is your x1, y1. And then if you're moving counterclockwise, okay, this is your x2, y2, x3, y3, x4, y4, x5, y5. Okay, so let me take a screenshot of that so that I don't have to look back. Okay. There we go. Yeah. Okay. So again, this is your x1, y1, x2, y2, x3, y3, x4, y4, x5, y5. So let's use our equation. So area equals, as you can see, 1/2. Okay, 1/2 that entire thing. So 1/2. Okay, let's start with x1. So that's 159.974 times y2, right? It's x1, y2. So y2 would be this 169.013, and then plus x2, which is 0, and whatever it multiplies it to is 0. So I'll just write it as 0 to save space, and then plus x3. So again, that's 30.551 times 0. So I'll just write that as 0. And then plus x4, 226.02 times y5. So 152.253. And then plus x5, 139.373 times y1. So you're going back to y1. So 340.64. Okay? And then minus, we're going to go the opposite way. So that would be x2, y1, x3, y2. So x2, okay, 0 times y1. So that's just 0. Okay? And after x2, you're going to go with x3. Okay? So x3, y2. So x3 is 30.551. Y2 is 169.013. Okay? And then plus x4, y3. So 226.02 times 29.933, and then plus x5, y4, which is again 0, and then plus x1, y5, 159 times 340.64. Again, let's check, is that the last one? So yeah, it's x1 times yn. So x1 times y5. And that's it. Please compute for this. What's the answer? Okay, please double check. We could be incorrect here. Okay, we're not getting the 3,000 thing. So what did we do wrong? X and y1. X1, yn. Okay. So it's not supposed to be this. So 151,974 times. It's not 340. It's yn. Right. So 139 times 0. Cancel 159 times 152.253. Okay. Okay, there we go. Who got 2,000? Nag-solve talaga. Okay, Ariel, thank you for actually computing, and Angela. So Patagalan and Lapid. So once again, please actually solve, because as you can see, I might write the incorrect value. So the answer here now is correct. It's 36320 and then rounded off to 2 decimal places, so 22. There's no unit here, I believe. Yeah. So let's assume here it's given in feet. Okay. So apparently the unit used here is in feet. So let's use feet. That's area, so feet squared. Again, in your exam, no worries. I'll give you the unit or what units are for each measurement. Okay. All right. So that's for coordinate method. Do you have any questions? Please answer in the chat. Okay, clear. Well, let's have the last question, I believe, for today. Hindi pa. Okay, second to the last. Next topic is triangulation method. So from the name itself, that's just dividing our lot into triangles. And then we're going to use equations for triangles to solve for the total area. Okay, so divide lot into triangles and trapezoids. These are your areas for triangles. It's 1/2 base times height, 1/2 AB sine C, sine opposite angle, or using S. I believe that's also Simpsons 1/3 rule, or not. But area is square root of S times S minus semi-perimeter. Okay, S is semi-perimeter. So square root of S times S minus A times S minus B times S minus C. Again, B, base of triangle, H, height of perpendicular to base of triangle, ABC sides, capital ABC angles, S is semi-perimeter, which is equal to sides over 2. And you already know the area of a trapezoid. Okay, so let's solve. An engineer set up a theodolite transit inside a triangular lot and observes the stations A, B, and C. Find the area bounded by station A, B, and C. Okay, let's do that. Triangulation. All right. So theodolite, you don't know what a theodolite is yet, but it's just an instrument where you can get distances and angles. Okay, so you'll eventually see what that is in your fieldwork. So theodolite inside a triangular lot, and these are the observations for stations A, B, and C. So to do that, let's have your position of theodolite. So again, I place that here on this dot. Next, let's look at A. A is distance from the transit. So point A to theodolite is 27, and it has this bearing. So to read bearing, you're going to start with either north or south, and then you're going to move by how many degrees, either west to east. So this is north 45 west. So we'll go north, rotate 45 degrees to west. So north, south, this is west, this is east. So that's why it's going here. Okay, therefore, and your point A is somewhere here. And okay, and then again, to get that, this was your north. Okay, and then this is your 45 degrees. Right? And then distance from theodolite to A is also given 27 meters. Next, let's look at B. It's 32 north, 60 east. So same thing. North, you're going to move 60 degrees east. And east is on the right. So it's here. And then afterwards, this distance is 32. 32 meters. Again, this is 60 degrees. And this is your point B. And then let's look at C. It's just 22 meters. And then just due south. So just go south by 22 meters. And that's your point C. And then these 3 points are the points of your triangle, right? Bounded by stations A, B, C. So meaning to get your triangle, it's just connecting your lines. So this. Okay. And so let me just rewrite the area 27, 22. 27, 32, and 22. Okay. So now we just need to get the area of this total triangle. So to do that, just divide it in 2 other areas, which will be convenient in solving. So let me just do this so that it's easier to see. Okay. So there's a number of ways to divide this area. You can do it this way, right? Or this way, whatever is easier. Now, you're going to base it on what's given. Remember, the equations are 1/2 base times height. Height is always perpendicular to the base. And no matter what you choose for the base, it's hard to compute for the perpendicular distance. Okay? So for example, if this is your base, I have to solve for this, which is hard. So nope, that's out. We're not going to use 1/2 base times height. Look at other equations for a triangle. We have 1/2 AB sine theta. So that means I need 2 sides and an included angle. So let's see. Let's look here. I have 2 sides. I just need to solve for this, which is easy because I already know what this is, right? So to get this angle, that's just 180 minus 60. So let's solve. 180 minus 60 is just 120, right? So I already know this is 120 degrees. So I can solve for this because I have 2 sides and the included angle. Now what about this? Same thing. I have 2 sides and I just take the sum of this to get the included angle. What about this? The remaining area. Again, 2 sides. I don't know what this is. But again, I can solve because this is given. So again, this total angle is 180. 180 minus 45 to get that missing angle. That's 135. Okay. And then let's also take this total angle. 45 plus 60, that's 105 degrees. Okay. So now let's solve. Let's divide this into our area. So let's say this is my area A. Okay. This is area B. And then this is my area C. Okay. All right. So let's do that. Start with area A, area 1. So A1, again, 1/2 AB sine theta. So AB are the 2 sides. So 22 times 32 sine angle in between 120. What's the answer? Correct, it's 304.84. So correct, Andre Kiben Escobar. 308, 304.84. So just store that. Okay. Store that in your calculator for easier retrieval if it's more than 2 decimal places. Next, area 2. Let's choose this, the violet one. Again, 1/2 base time, AB sine theta. So A, 27, B, 32, sine angle in between, that's 105. Please solve, what's the answer? Correct, Andre and Kian, Kiben Escobar again. Okay, 417. Again, store that. And then finally, area 3, 1/2 AB sine theta. So it's this one, the green one. So A, B, sine, angle in between. What's the answer? Correct. Jericho and Celica. So Angel, Laguno. A joke lang. My bad. Correct, Sampan, Gabriel, and Maria. Alyssa. So Pagalanan and Sampan. So it's 210.01. Again, store. And then to get total area, that's just A1 plus A2 plus A3. Please solve, what's the final answer? Okay, correct, it's who got it first? Correct, Jericho and Kian, but 2 points ka na. So next one is Zelica. So Angel, Jericho, Laguna. Okay, use the stored values, okay? Not the rounded off values in solving for 80. And again, units are given, so this is meters squared. Okay. That's it. Any questions for number 1, triangulation? Please answer in the chat. Okay, no questions. Let's have the final problem for today. Number 2. Okay, yan. Compute the area of the field measurements as shown. Okay, so we're just given that and we gotta get the area. So let me just, again, take a screenshot so I can just copy that. Okay. So to solve is the same way we did earlier, which is divide this into areas and then divide this into triangles or trapezoid and solve for the area. Okay. So I'll just solve for this on my own again to make things faster. Area 1, 2, 3, and 4 are already given. So you can see here area 1, area 2, area 3, area 4, and area 5. So let's start with area 1. Okay. So this is area 1, and these are your given equations. So what I'd like to ask is, what equation should we use? 1/2 AB sine theta, 1/2 base times height, square root of s times s minus a, etc. What do you think? Answer in the chat. Okay, good, John and Kian. No, it's the second one. So John and Kian. Puriscal Kitin. Okay. So one technique that you have to learn is which method should we use? So it's 1/2 base times height. Why? If you look here, okay, this line is actually perpendicular to this line. Because as you can see, there's a given 90 degrees. So that means that's perpendicular. This line is from a vertex to this side. So that's actually the height of your triangle. And then the base would be where it's perpendicular to. So I can use 1/2 base times height. Okay. So 1/2 base would be 830. Again, I'll just solve for this. No need to compute. Height is 30. You can double check if my computations are correct. So this will be 12,450. Okay. Next, area 2 is here. And as you can see, we have another line from a vertex to the opposite side, and its angle is 90. So therefore, that's the height. Okay, height is from vertex of opposite side, opposite angle to the opposite side, and it's supposed to be perpendicular. That's automatically the height, or the more correct term would be altitude of your triangle. So that's your altitude. 660, base is this. So our base is 790. So I'm going to use 1/2 base times height again. So 1/2 790. Height again is 660. And this would be 260,700. Okay. Let me know if I have any errors in computation as we go. Next, area 3 is this. So area 3 isn't that obvious because you don't see this jagged line, right? But take a look at your angles. This is again 90 degrees. That means this line and this line are perpendicular to each other, which means you have a right triangle. Area of a right triangle is also just 1/2 base times height. So base of this triangle is either this or this. Height is also either this or this. So let's say base is 800. So 1/2 800. Height is 200. So that should be 80,000. Why 790? Question here. Because it's the opposite side of your, or it's where your height is perpendicular to. Okay, so if you have a triangle here, this is your height, this would be the base. So looking over here, height is 660 because that's perpendicular here and on the vertex. So therefore, base is wherever it's opposite to, or meaning wherever it's perpendicular to. So that's why this is 790. Okay. Right, so that's A3 and A2. Next, let's have A4. So A4, the problem here is there's no given angle, right? This is supposed to be 90, but it's not given. But based on the drawing, we can assume this is as 90. Now, the answer in your handout also assumes this as 90. So let's do that first, okay? So since this is 90, this is again a right triangle. So 1/2 base times height. Let's say base is this, so that's 380 times height, which is 200. And you're going to get 38,000. And then finally, area 5. this is your area 5, which is not a triangle, it's a trapezoid. Okay, and then area of a trapezoid is base 1 plus base 2 over 2 times height. So if you consider this as your base 1, base 2 over 2, and then this is your height, then all we have to do is direct sub. So I know that this is the height again because as you can see, it's a line between your two bases and it's perpendicular because of this 90 degrees. So that's the height. So again, base 1, so 200 plus 720 over 2 times height, which is 250. Solving for that, we should get 115,000. And then total area is just A1 plus A2 plus A3. Getting the sum of all of this, you'll get 50,000. Hmm? Triangle HGI. HGI here. Okay. HGI is already included in this total triangle. That's already in your area 1. Okay. So it looks like this. This is the height. Yeah. Okay. This is your 830. This is your 30. And that's why this was already considered. Okay. All right. So going back, 50,000, 506,150 meters squared is our answer. Again, that's considering A4 as a right triangle. Now, what if area 4 not a right triangle? You have to solve for A4. So to solve for that, there's no angles here then. Okay. So let me remove that. There's no angles, but there's 3 sides. So I can use the semi-perimeter. And semi-perimeter is just 200, all the sides, A plus B plus C, over 2. And I believe that's 500. Yeah, and then to get A4, that's square root of S, which is 500, times S minus A, so 500 minus 200, times 500 minus 380, times 500 minus C, so 420. If we compute for that, okay, let me compute. We'll get 37,947.33 and compare that here. Okay, it's almost the same. So it's almost, if I round this up, that's also 38. So there's a discrepancy. And then if we're gonna go with this, our total area now would be, we're gonna use the same equation, but replacing A4 with this, we're gonna get 50,000, 506,097 meters squared. So these are our two possible answers. Okay, so or this one. Okay, so don't worry in the problem if we have something like this. If there's no 90 degrees here, don't assume it's a right triangle. Okay. So in our handout, the answer there given was assuming this is a right angle. So if on our quiz, don't assume. You have to check whether there's a symbol like this. If there's this symbol, that means it's 90 degrees. If there's nothing like that, don't assume. Okay, and that's it for problem number 2. Any questions? Please answer in the chat. Yes, you may also use trig functions to determine the angles if you want to. You can only use trig functions for right triangles though. So take note of that. B2 plus B1 over 2 times H. Yeah, that's the area of a trapezoid. Okay, sorry, I didn't see this. Bale, pag 90 degrees, gagamitin lang is yung 1/2 base times height kasi right triangle. Yes, if given base and height. If base and height not given, you have to use other methods like what your other classmates said. You can use trig functions to figure out angles and lengths. You can use sine law, cosine law to figure out all the missing parts. Okay. Any other questions, clarifications? For example, you're given this. You can't use 1/2 base times height because you don't know this and this, right? But you do know this is 30. So you can use sine law to figure out h and b. Okay, so this is 90. So 5 over sine 90. You can use trig functions or sine law. So for example, sine 30 equals opposite over hypotenuse. So sine 30 equals h over 5. You can solve for h. And then you can solve for b as well. So that would be cosine 30 adjacent over hypotenuse 5. So you can solve for 5. You can solve for b. Once you know b, you can use 1/2 ab sine theta to compute for area, or you can solve for h to use 1/2 base sine theta. Again, there's a number of ways to do this. Just make sure your methods are applicable for the triangle given. Okay? So no more questions, clarifications? Right. So that ends our topic for today. On Saturday, you'll have your seat work number 1. So there's no Zoom meeting. Just answer it on your own time. Deadline will be Saturday, 11:59 p.m. Answer the assessment and upload your solutions by then. Ma'am, ano pong susundin na sagot yung ginamitan ko ng Heron's formula or yung right triangle? Okay. So, in the quiz, if there's a symbol like this, or if there's 90 here, then your answer should be this. Okay? And again, in your quiz, if there's nothing here, there's no mention of this being a right triangle, then your answer should be this. Okay? Yes, the format of your solution would be value up to 2 decimal places. So let's say 16.14, a space here, and then your unit. So meter raised to 2. That's the format of your answers. It's going to be mentioned in the instructions as well for your quizzes. I have 3 items, I think, for your seat work. No, through submission link. So I'll give you an example. I'm gonna upload it on Saturday as well, so you're not gonna see it yet, but it's gonna look something like this. Let me give you an example. Seat work. Yeah. For example, here, seat work. You're gonna answer this, and then you're gonna upload solution here. You're gonna see it under week 2, because this is week 2. Okay. For this example, this was under week 6. And when you open this, and you'll see your instructions, and then you're gonna answer this. Okay. After answering that, upload your solution here. Okay. So that's how it's gonna look under week 2. Right. Week 2, di ba ngayon? Any other concerns, clarifications? I'm not sure how many items. I think 3. No more? There's no time limit for your seat work. You can do it the whole day. There's only 3 attempts, I believe, though. Yeah. Only have 3 attempts. No, your final grade would be the highest attempt. Okay. Yes. We'll have field meeting tomorrow, 12 o'clock. Okay? So please attend your field meeting tomorrow. Again, 12 o'clock. Okay, any other questions? Okay lang, you can be absent. Just make sure some of your members are there to relay the info. Okay? So tomorrow is more of like a consultation if you have any more questions for your fieldwork or clarifications, some added info and such. Since the actual video for your fieldwork was already uploaded. So consultation tomorrow. Okay? Wala nang hahabol? Any more questions? No more clarifications? Okay. So since you don't have any more questions at this day, okay. No, I've already uploaded it. Your video for a video recording for this lecture is later or tomorrow. I'll upload it later tomorrow for this recording. The video demo for your fieldwork is already up. Okay, so just watch that. Okay. So that's it. No more questions. You may go. See you next meeting. Tuesday next week. Goodbye, class.
Thank you, ma'am.
Thank you po, ma'am.
Okay, bye-bye.